Hello everybody, getting ready to do lesson 5.2 part 2 today of pre-calculus math. Email me here for questions and today verifying trigonometric identities part 2. We got 2 points here that will go into your notebook, and then we got 46 points here that will go into your classwork sheet. Today's bell work, teachers. Have your students use a graphing calculator to construct a table of values for these functions here. Then sketch the graph with a function on these grids here, and then identify asymptotes and put your asymptote identification in these response boxes here. Give your students about 4 or 5 minutes for that. Okay, welcome back for today's solutions. On our bell work, for up here you have a horizontal asymptote of y equals 1, which would be about here as x goes to negative infinity. So as x goes to negative infinity, your y equals 1 will be a asymptote for that. And then here is a table of values for this function up here, 2 to the negative x plus 1. And then here would be your graph here. So this would be your asymptote here, y equals 1. And then down here, for this one down here, f of x equals 2x to the minus 1 plus 3. We have a horizontal asymptote here as as 3. So we have an asymptote here of y equals 3. Here's your table of values for this function here. Students, which you should have on your graphing calculator, and then this would be your graph of 2 to the x minus 1 plus 3. And then here is your horizontal asymptote at y equals 3. Okay, into our lesson today, page 1. In example 2, and then back in part 1, you needed to write the Pythagorean identity sine squared u plus cosine squared u equals 1 in the equivalent form, which is cosine squared u equals 1 minus sine squared u. When verifying identities, you may find it useful to write Pythagorean identities in one of these equivalent forms. So we have Pythagorean identities, and then we will have equivalent forms here. So this is a Pythagorean identity here, sine squared u plus cosine squared u equals 1. An equivalent form would be sine squared u equals 1 minus cosine squared u, or cosine squared u would equal 1 minus sine squared u. So these will be equivalent to this expression here. Again, getting back into equivalent forms, 1 plus tan squared u equals secant squared u. So an equivalent form of that would be 1 equals secant squared u minus tan squared u. And then tan squared u would equal the same thing as secant squared u minus 1. So you're seeing, I hope, how we go from here to each one of these forms, right? We're just solving this way for 1, and then down here we're solving for tan squared u. And then 1 plus cotan squared u equals cosecant squared u. An equivalent form would be 1 equals cosecant squared u minus cotan squared u. And then cotan squared u would equal cosecant squared u minus 1. So these would all be equal to this over here. These here will be equal to that. These will be equal to that. Okay, let's get into an example now of using these equivalent forms. Verifying a trigonometric identity. Verify the identity tan squared x plus 1 cosine squared x minus 1 would equal negative tan squared x. So, by applying identities before multiplying, you obtain the following. So tan squared x plus 1 multiplied by cosine squared x minus 1 would be equal to secant squared x times negative sine squared x. So from here we yield that, and from this quantity here we yield this here to secant squared x. So now when we put these into a reciprocal identity, cosine squared x is the same thing as secant squared x, 1 over that. And then the negative sine squared x, we leave that up in the numerator, but we keep the negative sign here. And this would be using reciprocal identities. And then when you have this, and the negative of sine x over cosine x squared, property of x, which would be the same thing as negative tan squared x, a quotient identity from that. And then a graphical solution for this to check it on your graphing calculator. Here is y1, which would be tan squared x plus 1 times the quantity cosine squared x minus 1, which would be these curves. These I guess they're upside down parabolas. And then y2 would be the negative of tan squared x, which would be the same curve. So it checks by graphing it. It shows that these two here are equal to each other by using a graphing calculator. Because the graphs appear to coincide, the given equation appears to be an identity. Let's try one now. Use a graphing calculator to check your result graphically. So we have all this here on this side equals to 1. So how are we going to get from here to here is the question. 2 times secant squared x times 1 minus sine squared x. From this here, we're going to break this down into these two quantities here, x times this quantity here, minus sine squared x plus cosine squared x, which would be from these two here would end up down here like that, and taking a negative though, so you have a sign change here from that. Then 2 secant squared x times cosine squared x minus 1. This equals 1. This is the same thing as cosine squared x. So we end up with 2 times this secant squared x becomes cosine squared x times cosine squared x minus 1, which is this here, cosine squared x minus 1. And then this becomes 2 times, this is the same thing as negative 1 here, negative 1, which would equal 2 minus 1 would equal 1. This becomes 2 over cosine squared x times cosine squared x minus 1. This would equal 2, and then you subtract this 1 from this quantity here, and you have 2 minus 1 would equal 1. So it's kind of an elaborate layers of Pythagorean identities. And then down here, cosecant x times cosecant x minus sine x plus this quantity here plus cotan x equals cosecant squared x. So cosecant squared x minus cosecant x sine x plus 1 minus cosine x over sine x plus cotan x. So cosecant x minus sine, we're going to just put our negative sign out here, negative cosine x sine x plus 1 minus cosine x over sine x plus cotan x. This becomes this over here, 1 minus cosine x over sine x because of this here, 1 minus that, and then we're going to add our cotan x here. We're trying to get this to equal cosecant squared x there. And then this becomes cosecant squared x minus 1 plus 1 minus cotan x plus cotan x. So this is cotan here. It would be a negative cotan x plus cotan x. So these will cancel out. And then cosecant squared x minus 1 plus 1. So negative cosecant x sine x becomes a negative 1 here, and then you're adding your negative 1 to here. So again, you're breaking these down into Pythagorean identities so you can reduce this into this form up here. Equals cosecant squared x. So x minus 1, x plus 1 minus cotan. These cancel, and then x minus 1 plus 1, these cancel out, so you're left with cosecant squared x is what you're left with. So after breaking these down into Pythagorean identities, you do indeed end up with cosine squared x. Okay, converting sines, cosines, verify the identity tan x plus cotan x equals secant x cosecant x. So let's try to work that one through. In this case, there appear to be no fractions to add, no products to find, and no opportunities using Pythagorean identities. So try converting the left side to sines and cosines. So this over here we need to convert over into sine and cosines. So tan x plus cotan x is the same thing as sine x over cosine x plus cosine x over sine x. And then once we've done that, sine squared x plus cosine squared x, cosine x, sine x, we're going to add these fractions now to do that. We end up with this up here in our numerator. And then we end up with a 1 over. This is equals to 1 up here over our denominator, which is cosine x, sine x. And then now we can multiply cosine x times sine x, and we get secant x, cosecant x as a reciprocal identity. Okay, into our example now. Use a graphing calculator to check your result graphically. So we have cotan x times tan x over sine x. Will that come to cosecant x for our guided practice, and then your independent practice, which I've been doing lately? I mean, we can go over this together. 1 plus cosecant theta over secant theta minus cotan theta. Does that equal cosine theta is the question. Okay, so getting into our solutions here for our guided practice, cotan x, tan x, these are inverses of each other, so that goes to 1. And then we have 1 over sine x, which is, guess what, the same thing as cosecant x, so that one solves itself there. And then down here, 1 plus cosecant theta over secant theta minus cotan theta, does that equal cosine theta? Well, cosine theta here, this will come into this. Secant, or rather cosecant, is 1 over sine, so that takes care of that. And then secant is the same thing as 1 over cosine. So when you flip that back up, that becomes your cosine here, and then your 1 stays there. So you have cosine, which was your secant, turns into cosine, times quantity 1 plus 1 over sine theta, which is cosecant, minus cosine theta over sine theta, which is cotan. So these two cancel each other out here. And then cosine theta times 1 is cosine theta. So that proves itself out there. Okay, recall from algebra that rationalizing the denominator using conjugates is on occasion a powerful simplification technique. A related form of this technique works for simplifying trigonometric expressions as well. For instance, to simplify is 1 over 1 minus cosine x. Multiply the numerator and the denominator by 1 plus cosine x. That'll be a conjugate of that. So when you do that, this is your setup here for that. So we want to get rid of this 1 minus cosine x in the denominator, and then this becomes 1 plus cosine x over 1 minus cosine squared x, which, guess what, is equal to sine squared x. So we have 1 plus cosine x over sine squared x, which will become cosecant squared x. This will become cosecant squared x times the quantity 1 plus cosine x. Okay? In your notebook, students, cosecant squared x times quantity 1 plus cosine x is considered a simplified form of 1 over 1 minus cosine x. So we go from here to here. It's a simplified form because we don't have we have a denominator here of 1. We don't have a complex denominator like that because the expression does not contain any fractions. So this is preferred over this here, in other words. Okay, moving on to our next example here. Verifying a trigonometric identity. Verify this identity here. Secant x plus tan x equals cosine x over 1 minus sine x. Begin with the right side. So we're gonna get over here because you're going to create a monomial denominator by multiplying the numerator and the denominator by the conjugate of 1 minus sine x, which is 1 plus sine x. So when we multiply through by 1 plus sine x times cosine x and 1 minus sine x, we get cosine x plus cosine x sine x over 1 minus sine x sine squared. And then when we do that, we end up with this, and we have a Pythagorean identity here now, which is cosine x over cosine squared x plus cosine x sine x over cosine squared x. So we separate our fraction. This cancels out here. We have 1 cosine x plus sine x over cosine x. Let's see here. This cosine, see sine x, and then cosine x. Yeah, this will cancel here, so you end up with this cosine x there. And then now 1 over cosine x is secant x, and this is tan x here. So secant x plus tan x. So it proves out to be that. So the graphical solution, if you graph both of these, secant x, tan x, we'll end up with this. And then cosine x over 1 minus sine x, you'll end up with the same graph on your calculator. So that'd be one way that you could check it. You should check it doing that. Okay, into our guided practice. Use a graphing utility to check your result graphically here. So we have sine beta over 1 cosine beta equals 1 plus cosine beta over sine beta. So let's do guided practice. So you end up with that. We're going to get rid of this here. So we multiply both numerator and denominator by 1 plus cosine beta. We get this down here, 1 cosine squared beta over, or rather underneath sine beta times 1 plus cosine beta. And that's a Pythagorean identity, which is equal to sine squared beta over sine beta times 1 plus cosine beta. And then these will cancel here. So you have 1 plus cosine beta over sine beta. And then down here, cotan alpha over cosecant alpha minus 1. At times, we need to get rid of this, so we're going to use the conjugate, which is over here, numerator, denominator by that. And we end up with cotan alpha times cosecant alpha plus 1 over, excuse me, cosecant squared alpha minus 1. Okay, so cotan alpha times quantity cosecant alpha plus 1 over cotan alpha here, cotan squared alpha. And then these will cancel here, and we'll end up with cotan alpha underneath cosecant alpha plus 1. So let's see here. We went from cotan alpha over cosecant alpha minus 1 to cotan alpha here. So cotan alpha here, cosecant alpha minus 1. This identity here just turns into cotan squared alpha. That's a Pythagorean identity. So now these will cancel, and you'll end up with that. Cosecant alpha plus 1 over cotan alpha. And that is your part 2 of your lesson today of pre-calculus math. Email me here for course materials and questions. Thank you very much.